So by now you should have set up your own Bitcoin reg test, Bitcoin IPC and IPC CLI. Let's now start creating the Bitcoin wallets and configuration files we're going to use in our demo. You have an option to do a manual setup, but you also can use the quick start binary that we're going to use in this demo. So we see that we have configuration files generated for all our parties. We have Bitcoin wallets created for us, for all the validators and users. They are funded with 100 Bitcoin each. And we also have a pretty print of all the Ethereum addresses and X-only pub keys we're going to use. So let's now go to our .ipc and change our Bitcoin Core RPC username and password. So you see by default, we have the RPC user and pass be user and pass. I'm going to change this to my own username and password in all the files. I'm going to save all. If you're following the demo with the quick start binary, you can use this handy export list, so we don't have to copy paste the addresses and the whitelist. So let's paste it here. Let's double check our IPC directory has the same structure. So we have user 1, user 2, validator 1, validator 2, 3, 4, 5. The .env is what the monitor and provider use, and the config.toml is what IPC CLI use. Each validator has a validator secret key inside its own configuration subdirectory. We can also find all the keys here inside of the btc keystore.json. If you want to understand a bit better what the quick start binary does, you can take a look at the manual setup here. Going forward with the helper scripts, there's a few scripts that are going to be useful throughout the demo to understand what's happening inside of L2 and also work with Bitcoin. You should mark all of them as executable, and we can start immediately running the miner, which will mine a new reg test block every 10 seconds. Some of the L2 scripts we're going to be using throughout the demo. You can read as to what they do, but we're going to come back in the later steps. Let's now run Bitcoin monitor and provider for all of our users and validators. So we have our 4 validators, our users here, and also we're going to be running the validator 5 afterwards. Okay, so let's now continue to subnet creation. We have a command here that we can copy and paste to better understand what's happening. So here we're specifying the configuration path of the validator who's going to be creating the subnet. In this case, it's validator 1. The subnet creates subcommand. Parent is B4, meaning reg test. We're specifying the list of the number of minimum validators, which is 4. The bottom-up check period, this is the number of L2 blocks, after which there's going to be a checkpoint to Bitcoin. We also provide a minimum validator stake, a minimum cross-message fee, and also our validator validators, which is the list of X-only pub keys that we allow to be joined for bootstrapping. Here you see when we pasted this command from the documentation, we already specify our 4 validators here. So let's send this, and we see that we have the new ID submitted, printed, by the command. We can make sure that all of our validators actually process the message. So you see process create subnet for subnet ID and the ID here specified. So let's go back to the documentation, and we see that the documentation suggests we save this new subnet ID like so. Which we'll do. I'm actually going to paste this subnet ID across other terminal windows, which we're gonna need to have. I think this is okay. We already started the miner. Yes, so with the new subnet ID, let's now go back to the configuration files and change the subnet ID for subnet A. So we see here, and let's get our new subnet ID. We save all the configuration files. And let's now join the subnet by the 4 validators that are whitelisted. So if you can see, these are pretty identical commands, but we're going to go through one of them as an example. We're specifying the validator who's submitting the request with the subcommand subnet join. We're specifying the validator 1 address that we had copied from the documentation. The subnet ID we just defined, specifying Bitcoin, the number in Satoshis of the collateral we're going to send, and some information about our validator. So let's send these. After a new block is mined, we should be seeing this in our monitors. And as we do, we see that the 4 join subnet has been processed. So after we have joined our validators, let's now fund them so they can interact in the subnet. So we see 4 identical commands, one for each validator, with the cross message fund subcommand specifying the subnet ID, their address in the subnet, and then the amount in Satoshis to fund. Let's send to Bitcoin. And in the next block, we should be seeing these messages got picked up by the monitor. And we do. So we see process fund subnet. We see the address of the validator and the amount. And we're seeing 4 of them. We're now ready to deploy the validator infrastructure. To deploy the validator infrastructure, we have 2 options. We have the manual deploying infrastructure, or we have the automated scripts. For the demo, we're going to use the automated scripts, but feel free to look at the manual deployment methods to better understand what's going on. We have the spin up subnet A helper script, which we're going to use. Okay, so this took a few minutes, but we see that our 4 validators have been started. And also we see that there's some useful information about the bootstrap that we're going to use later, so please note of this. Now let's also verify that our Docker containers are running, and we see 3 containers for each validator, one being Fendermint, Common BFT, and 1 Ethereum API. We can now check the status of the subnet. We can print the block heights here, and we see how the subnet is progressing. And also we can print the balances of the subnet. And as we do, we see our 4 validators having funds we sent to the subnet. Let's now interact with the subnet, and as a prerequisite, we should be starting our own relayer, which you can read what it does here, but relayer practically is going to be sending checkpoints and other bottom-up messages to Bitcoin. Let's get the subnet ID here. Let's copy the command. In this case, the validator 1 will be running the relayer, but any one can do so, and there can also be multiple relayers at the same time. Okay, and we see it actually started already submitting some checkpoints. As a step 2, let's fund a user. So as you can see, we're specifying the user 1 configuration. We're using the same cross-message fund as we did for the for our validators. So we can see that in the next block, we have the fund subnet event being printed as with our address of the user. We can also see in the subnet that the user now has balance. We can also double check that our user's Bitcoin wallet was deducted by the fund. So we see that we have 1 Bitcoin less and some extra for the fees. What we can also do is get our user's balance directly using cast balance from the Ethereum API RPC. And we can see we have 1 Bitcoin with 18 decimals here. Let's now demo the release of Bitcoin back to L1. So this is what our user had before. We will use the cross-message release command, specifying the subnet ID, the address we want to release from, and the Bitcoin address to send to on Bitcoin alongside with the amount in Satoshis. So we see that the balance in the subnet has been updated, and we need to wait for a checkpoint to be submitted on Bitcoin to actually see the balance updated. Let's see if we already might have it. Okay, we do have a checkpoint submitted, and let's now see that the balance has been updated, and we indeed see that the balance has been updated by half a Bitcoin here. So in order to demonstrate the cross subnet transfers, we need to set up and start infrastructure for the second subnet. We'll use the exact same command as we did for subnet A. And let's make note of this new subnet. First inside of our terminal, but also in our configuration. Let's save all the configuration files. And let's check the monitors, as we should be seeing the new create subnet message being processed as we do here. Let's continue. We're going to join our validators to the subnet. We'll wait for the new block to be mined, and we see the 4 joins being processed here. Last thing is to fund and deploy the validators. You'll notice that we will be using the spin-up subnet B helper script with the new subnet ID. So after a few minutes, we see that our subnet B has been deployed, and we can verify by looking at all the new containers we got. So we see subnet B, subnet B, subnet B, and subnet B here. We can use the same block checker and balancer scripts to now take a look at the subnet B. So L2 block checker and then the balancer. Let's now demo cross-chain token transfers. For step 1, we will set environment variables for ease of use. Let's copy the command. And we see that first of all, we're specifying the configuration path of the user 1. So user 1 will be sending some money, specifying the cross-message transfer command, source and the destination subnet, source address, and destination address. So we see that we're sending some number of Satoshis to user 2. And let's beforehand note of the balance of user 1, and user 2 will see its balance being updated as well. So this is now sent, and we can immediately see that the balance is lower in subnet A, but in order to see the increase in subnet B, subnet A needs to be checkpointed to Bitcoin, so let's wait a few blocks for it to be checkpointed. So after a few blocks, our subnet A was checkpointed to Bitcoin, and we can now see that our user 2 has a new balance in subnet B. Let's now demonstrate validator operations within a subnet. We'll start by demonstrating joining of an additional validator. We can use our helper script to list the current validators. This will query validator 1 common BFT RPC to list the current validators, alongside with their voting power proportionate to the stake they put in. Let's run monitor and provider for validator 5. And let's also make sure that we have our subnet ID specified to be the first subnet. We'll now use the subnet join command that we previously used, but now specifying validator 5. We're using the subnet join and specifying here the collateral. And we do see the join subnet message being printed. Let's now fund our validator 5. We see the fund subnet message being printed. Before we start the Docker container for validator 5, let's update the subnet ID here, and let's also use the parameters from subnet A and put them in our terminal. Let's now copy the cargo make. So here we're specifying some default parameters and alongside with the subnet ID and the node name being validator 5. After a few moments, we see that our fifth validator's node has been started, and we can double check that indeed we have our 3 containers running for validator 5. Let's now view the status of our validator. So as you can see, our fifth validator is still catching up here. So it's presenting its voting power 0, but validator 1 knows that there are now 5 validators with some new voting power. Let's now demonstrate staking additional collateral, and now we're going to be doing this for validator 1. So as you can see, we're using the subnet stake command, specifying the subnet ID alongside with the collateral and the validator address. So we see our monitors pick up the stake collateral message, and let's now go back to the validators here and actually query the validator status of 1. And as you can see, we're now seeing the updated voting power to 3000, and the same here. Let's now demonstrate the unstake collateral. We're going to be lowering the stake for validator 1 by half a Bitcoin. So pretty similar, but now using the unstake versus the stake, specifying the subnet ID and the collateral. As we can see, here our monitors picked up the IPC unstake collateral message. So after a few moments, we see that the voting power of validator 1 is lowered. And finally, let's demonstrate the leaving of the subnet. And here we're going to be leaving validator 5. We do this by using the unstake command and specifying all of the collateral. So after a few moments, we now see that validator 1 doesn't have validator 5 in the list of validators, and we can also query validator 5 and see that it itself has no voting power. So as a final thing to demo, let's say the validators want to kill the subnet. So this is announced by one of the validators proposing a kill. So using the IPC CLI, let's send the kill request. So here we see that the kill request was posted to Bitcoin, and we see that the majority wasn't reached. So to reach the majority, others must vote as well. But before this, let's just have the previous balances here of the validators, just so we can compare after the final unstakes. And let's proceed with voting for the kill. Validator 2 and Validator 3 will vote for the kill as well. So after a new Bitcoin block has been mined, we'll notice the messages. So we see that the 2 new kill requests have been submitted to Bitcoin, and we see here kill request majority reach for subnet, marking subnet pending killed. So now all the users have next 5 checkpoints to withdraw any pending funds before the subnet is deemed killed. Let's just verify that it is pending killed, and we can see that in the helper scripts, one of the helper scripts is the get subnet. So we can see the state there, and let's paste here. And we see that the status of the subnet is to be killed. We can also take a look at all the kill requests with the get kill requests helper script, which is also described here. And the output is here. We can see that the 3 validators who voted, the block height when they voted, and the transaction IDs. So after 5 checkpoints, if we query the subnet again, we can see that its state is killed, and we can see that our validators have their collateral and any remaining funds split between them back on Bitcoin. After this, the subnet is no longer connected to L1, and the Docker containers and all the infrastructure can be safely stopped.